Hey everyone, and welcome to another mathematics lesson where today we'll be talking about conic sections. So a conic section is any of the several kinds of curves that can be produced by passing a plane through a cone as shown in these four images. So I'm just going to walk you through each of these four schematics. So the first one would be if there is a perpendicular plane which has the theta equaling 90 degrees. The eccentricity would be 0. Option B, which is the second from the left, would be an ellipse, and that's when the theta of the inclined plane is less than 90 but greater than the theta value. The third option being a parabola, and that's when the theta is equal to the theta value. And then lastly we have hyperbolas, where the theta of the plane is at 0 degrees shown. So this is a quick little introduction to how these planes cutting through the conic sections can produce certain sections for the conic section, and we'll get further into this in future videos. And then lastly, for this quick slide, the eccentricity of a cutting plane, which is the variable e, which I've shown in each of these schematics, can be determined by doing the cosine of the theta, which is the cutting plane angle, divided by the cosine of the theta, which is the angle of the conic section across the vertical axis. All conic sections are described by second-degree quadratic polynomials with two variables. So the general form of the conic sections equation is given here, where x and the y are variables and a, b, c, d, e, and f are constants. H and k are the coordinates, so it would be h comma k of the conic section center. R is a size parameter, usually the radius of a circle or a sphere. And if r is equal to 0, then the conic section describes a point. So if r is negative, the equation does not describe a conic section. So now if a were to be equal to c, then b must be 0 for a conic section. If a is equal to c and is equal to 0, the conic section is a line, and if a is equal to c and those are not equal to 0, the conic section is a circle. And then if a does not equal c, we have these three scenarios where the b squared minus 4ac, if that is less than 0, the conic section is an ellipse. If it is greater than 0, the conic section would be a hyperbola. And then if it would be equal to 0, the conic section is a parabola. So the general form of the conic section equation can be applied when the conic section is at any orientation relative to coordinate axes. So in the second equation, the normal form of the conic section equation, it can be applied when the principal axis of the conic section is parallel to the coordinate axis, thereby eliminating certain terms of the general equation and reducing the number of constants needed to 3. Which are A, B, and C. Now we're going to finish up this quick little introduction to the conic sections with a example problem. Okay, so to quickly introduce and kind of implement what we have just introduced to you guys regarding conic sections into a real mathematics problem, we're going to show you guys an example of asking you what kind of conic section is described by the following equation. The equation being 4x squared minus y squared plus 8x plus 4y equaling 15. So the options for the conic sections that I have introduced is circle, ellipse, parabola, or hyperbola. So we're going to start with the general form of a conic section given the equation, which is ax squared plus bxy plus cy squared plus dx plus ey plus f, and that it will equal 0. So in this form we are able to determine what these constants are. So a would be 4, b would be 0, c would be -1, and since a does not equal c, the conic section is determined to be not a circle or a line. So now we're going to calculate the discriminant, which is the b squared minus 4ac, and when we plug those variables or constants into those values, we get 0 squared minus 4 times 4 times -1. And that, if you put that in your calculator or do the proper math, you'll get a value of 16. And since 16 is greater than 0, that will tell us that this conic section is a hyperbola. So that will be option D. So I hope you guys enjoyed this quick crash course on conic sections. There are going to be several other videos under the conic sections category. So I hope you guys stay tuned for future videos. Make sure to like and subscribe for more mathematics and engineering related content.